Hello everyone. This is a presentation about air traffic control. It is presented by Mansa, Nikita, and Charishma. Here is the outline of our presentation today. Coming to the motivation and goals, we represented accurate and reasonable depiction of the airlines travel between the US Atlantic states. We ensured the safety management of the aircraft movements by tracking their positions, routes, and status in real time. We also represented moving objects. Coming to the data sources, we collected the data from MATLAB I2V2C and JPEG map for the state constraint relations of the Atlantic states. We also took the data of airports and aircrafts from real-time data, airport locations and codes from our airports.
This is the ER diagram of our project. We have 6 entities. They are pilot, aircraft, aircraft type, communication log, airline, and airport. And we have 7 relationships which are flown by, belongs to, generates, operated by, works for, based out of, and serves. So we have one-to-one relationship between pilot and aircraft. One pilot flies one aircraft, and we have many-to-one relationship between aircraft and aircraft type. So many aircrafts can belong to one aircraft type. And then we have one-to-many relationship between aircraft and communication log. So one aircraft can generate multiple communication logs. And then we have many-to-one relationship between aircraft and airline. One aircraft is operated by many airlines. And then we have many-to-one relationship between pilot and airline. So many pilots can work for one airline. And then we have many-to-one relationship between pilot and airport. Many pilots can be based out of one airport. And at last, we have many-to-many relationship between airport and airline. So many airports and many airlines can serve one airport. So this is about the ER diagram. We now see the design overview. We have 7 tables here, which are aircraft, aircraft type, pilot, airline, airport, communication log, and serves. So for aircraft, we have call sign as primary key and pilot ID, airline ID, and log ID as foreign keys. For aircraft type, we have ID as primary key. For pilot, we have pilot ID as primary key and airline ID, airport ID as foreign keys. For airline, we have airline ID as primary key. For airport, we have airport ID as primary key. And for communication log, we have log ID as primary key. And at last, serves is a many-to-many relationship table. It has airport ID and airline ID. This is about design overview.
We used MATLAB and I2V2C.m script to calculate constraint values. JPEG image of Atlantic states in the US were used as the input. And here is the visualization of the map of the Atlantic states of the US. It is run in the MLPQ with the output file which is generated from the MATLAB. And here is a small demo of the animation which will visualize the geographic and moving objects. The light blue are the airports and the dark blue are the airplanes.
These are our functions. Coming to the first query, we find out all the aircrafts while flying over North Carolina at a given point of time. So the query type is basic SQL. So with this, we get 2 aircrafts which are flying over North Carolina at any point of time, which are B456 and F123. This is about the first query. And This query is to find the number of airlines operating in each airport. And for this, we are using aggregation query. So the output is something like this. For airport 1, we have 5 airlines operating there. And for airport 2, we have 4 airlines. Airport 3, we have 3 airlines, and so on. This is query 3. In this query, we find out all those aircrafts which are flying over Virginia or North Carolina at any point of time. For this, we are using sets query and we are using union operator. In our output, we can see 4 aircrafts which are A123, E123, B456, and F123. So these aircrafts are flying over Virginia or North Carolina at any given point of time.
And in this query, we have find the speed of the aircraft at a given location. And we have used the SQL sets. And the relation we have used is intersect. And the results are here. And there is another query here where we find the fastest aircraft and the pilot. And we have used the nested SQL. And the results.
Coming to the conclusion in the future work, in the future work, we thought of doing more advanced analytics, which will focus more on the air traffic patterns, and which also will focus on the weather conditions. Uh, we also thought about using the satellite data, which makes it more practical in getting the real time tracking of the aircrafts, especially in the remote areas. We also thought of doing a global air traffic network. Thank you all for listening this presentation.